Good afternoon to all of you. We are here for this final speech that I'm proud to announce because it's regarding security, and I am one of the people for the security track here in Codemersion. So for me, it's very good to have this final keynote from Dinis regarding application security. 2 words regarding Dinis Cruz is one of the father, we can call it this way, not, regarding the OWASP, that is specialized on application security. He is the owner of the O2 platform that is specifically related to the software development life cycle regarding security. This is a very important matter in this moment. It's a very important topic because in this moment we have a lot of trouble that are related to application security. All the software that we develop, both for things that are related to websites, for example, but also related to embedded systems, comes from software, application software. And security is not something that needs to be managed by the security manager, by the IT security manager. It's something that is related to all the people that develop something. So developers, system administrator, network administrator, and so on. It's something that must be shared along all these kind of people. And Dinis is one of the people that try to explain that this is a very important thing. What we will talk today is why application security, why develop in a security way must be the most important things relating to developing something. This is the first things. The second thing is how we can put security inside the development application cycle. Because this is the real trouble. This is very complex because usually you have to develop things in a short amount of time. And security is the last things that you can take in care. And this is the trouble that we have with the modern software. So please listen very well to what Dinis has to say to us. And thank you for coming. And please tell to us what we are talking about.
All right, thank you. Oh, I don't need that, right? Okay, so to start with, just and actually the theme of this is New Year of Software Development with Modern Application Security. So I'm basically going to show you how a lot of the stuff that we're doing in application security for a while actually can make you develop better and can actually improve your worlds and can really make a difference when you're coding. So a couple of disclaimers. I actually have 233 slides on this thing. So I did it for 2 reasons. First of all, because I actually want to stay on script because I ad-lib very well, but I can ad-lib for 3 days. So I kind of wanted to put my message. Also because I want you guys to be able to read and go back to the materials. So I also speak very fast, which is kind of a problem. And even when I do 3 days, right? Even when I do 3 days, people come out of it going, it was great, but it was too fast, right? So I also abuse the term unit testing a lot. Because for me, a unit test of the unit part of the test is anything, right? That go from the smallest method to the full workflow. In fact, the way I look at it, if it can be executed by a unit test framework, it's a unit test. Right? That's the kind of thing, right? Because unit test framework is basically something that is repeatable. You can code it. You can do it every time. For me, that's a unit test. So when I talk about tests, think of, kind of the whole picture, right? I've been coding for ages. I'm from the Spectrum generation. If any of you guys remember the Spectrum and the Amiga, and when the 286 was, very fast, and it still sucked because the Amiga was so much better, right? And the whole stuff. I'm doing AppSec for ages. I met Matteo, right? In the thing, and we actually are from the generation that we used to say, AppSec is really important, this is really going to blow up, right? And then now it actually is blowing up. So in a weird way, it's nice, but it's also bad because we actually wish we were in a better position than we are today, right? I actually have some interesting day jobs. This is my open source project. I'm actually kind of moved from the vendor and from the guy that destroys and breaks applications to actually work on the other side. So in a way, I kind of do this thing where I kind of help to run application security teams for companies who kind of want to go to the next level. I also do a lot of training for this company in the UK, and I kind of do a lot of consulting and mentoring to people who are kind of doing it but kind of want to improve it. So I've done a lot of security reviews. I've found a lot of stuff. I've been there, done that, reported 0 days. Actually, it's a bit weird because I see a lot of people making a lot of money for vulnerabilities that you almost feel like I should stop a couple of months and just kind of find vulnerabilities because that's actually almost viable as a business model now, right? But in a way, it's kind of this is the kind of stuff that's very interesting until you've done it a while, and then one day you find your own credit card in there, one day you find your own debt, and you go, actually, this is not a joke anymore, right? It's not about finding problems, it's about fixing them. Okay, so I've done training for a lot of people. I'm actually a developer, I'm very proud to say. I wasn't 4 years ago. I've been coding for 23 years, but I never really shipped code. So I've now shipped code, I've managed dev teams, I've written tests with 100% code coverage, I've created DevOps environments, I've created architectures. I feel I evolved. I think I understand much better now what happens in development and why, in a way, security struggles to fit in, right? I love graphs. I kind of had to put in there because somehow it was one of those things where I realized, I had this epiphany about a year ago, I realized most of my time I've been playing with graphs. And if you guys haven't played with graphs, you should, because actually, in a weird way, relational databases are not very good for relational queries. It's really ironic. But again, that's kind of for another talk, right? So my blog, my Twitter, my blog, I got some books when I'm putting on LinPub, they're kind of work in progress. You can just set the price to 0 and get them for free, right? And then O2 is kind of the thing I've done. It's kind of my brain in a tool. It's pretty messy. It's very powerful. It's still amazingly powerful today, right? Although I've been moving it from Windows to Nodes and to kind of Linux environments and OS X environments, but it's still really, really powerful. All right, I want to talk about the new era software with modern application security. And here's my concept, right? We can use application security to measure software quality, to define and to measure software quality. And this is very interesting because you'll see that sometimes it's very hard to define what we really mean by quality, right? But I'm sure most of you guys passionately believe on it, right? So I think there's a very interesting common ground between the things that we want to do in application security, make it safe, make it predictable, make it robust, and the things that you guys want to do in developers, right? So, because this is interesting, right? When you do modern application security, this is what you do. You do TDD with test coverage, you do threat models, you do Docker and containers, you do test automation, you do SAST, DAST, EAST, and WAF. If that doesn't make anything to you, right? I'm sorry, but that's the things that Gartner supports, and they produce magic quadrants and all that jazz, right? But also defines specifically sectors of the actual industry. Clever fuzzing, JIRA workflows, which is for me the thing that I really managed to figure out how to break the application. JIRA Risk workflows is how you hack an organization from the inside to make you do the right thing, right? And you'll see what I mean in a second for that. Kanban for quality fixes, web service visualization, and ELK, which is Elasticsearch, Logstash, and Kibana, right? And I'll go into more details about this. But this is what doing modern application security means, right? And in fact, if you guys, the guys who do security not doing this, well, they really should, because this is when you make a difference. And here's the JIRA workflow that I want to talk about. The key thing is that bit there, making risk acceptance, right? Because that's where you make sure that your boss is the one that gets fired, right? When the whole thing blows up, right? And I'll go in more details about that. So let's start with a view of the problem. I'm going to kind of speed through this because there's a lot of material out there. I don't really want to scare, well, you might be scared or not, depends what you know about this. But I kind of, going to do a quick overview. So software, is eating really the world. The whole thing is freaking software now, right? We've moved beyond the point where thinking, yeah, I know. Maybe not. Like these days, most companies, either they have accepted that they are a software company or they have not accepted. But most companies these days are software. They run on top of software. Without software, they just don't operate anymore, right? So, they do that kind of stuff. Now, who's actually attacking this? Now, this is very interesting, right? If the attacker tells you about it, regardless of what you feel, regardless of what your boss feels, regardless if you're the guy who woke up at 2 o'clock in the morning to clean the mess, he's actually your friend. Right? Because from a criminal point of view, telling you is the last thing you want to do. So, I don't care. The person has a grudge. The person, it was a bit of a, I'm not going to use a word here, but, he dumped all your data in a paste bin. Guess what? A criminal would have done way worse than that. So, at the end of the day, the real problem are the commercially focused criminals. These guys are the problem because it's all about the money. It's about scaling. It's about building enterprises that you will go crazy with the quality they have. There's criminal organizations out there that they're better than most software development companies. They have better customer support. They have A/B testing. They do the whole freaking shebang, right? They're amazing organizations, except that, they're criminals, right? So, and then, because what we're really seeing now is also the hacking as a service, right? We're seeing the cyber services for hire, right? So guys like this, the hacking team, these guys actually, they might be here, ironically, I just realized that they're in Italy, right? So these guys, you can pay them, right? If you're a government, theoretically, right? And they will hack stuff, right? Part of their business model is to own you guys, is to own your companies, is to sell your company access to whoever is paying them, right? And this is, by the way, this is legal, you know, which of course is the other side, right, of the dark kind of stuff, which is of course not legal. But these guys are borderline legal, and that's what they're doing, right? Now, you can get a botnet, 1,000 computers for $100. These guys have evaluation versions. They have the whole freaking thing, right? You can choose, you can pick the company, right? It's not that expensive. This is the cost. The way you need to read this is the cost of a 0 day. This is the cost of a vulnerability that you get a text message and your phone is now under the attacker control. You visit the website and they have put stuff in your actual application, in your laptop. Of course, your laptop is connected to a version control, which connect to your VPNs, let's go from there. But this is basically what they have to pay in the worst case scenario. Because most likely, you guys just go npm install and you download half of Node, and then you do npm, so Maven build, and you download half of Maven, right? And basically these days, all you need to do is compromise one of those, and you have that. Or you put one of your extensions. How many extensions you guys have on your laptops, right? But the bottom line here is that if your entire security model is based on nobody using one of these, none of you guys have malicious code in your environment, none of you guys use a particular dependency that has to be on control of somebody else, right? Nobody, if you click on a link that goes to a malicious website, that is a very tall order. In fact, of course, none of you is malicious, right? Or none of you has been paid to be malicious, for example, right? That doesn't scale, right? But this is the real cost today. This is literally how much it costs to own your company. So the interesting question is, how many assets do you have in your company? How much value it is your data? If I take all the data that you guys own, right? How much would that cost to you, and how much would it cost to a criminal to make it? And that's where you need to have the value. And that's why owning data is expensive. That's why when you guys want to plug to that web service, you really should be saying, great, of course you can connect a web service, right? But you need to realize that you now have to maintain 20 million pounds or 20 million euros of assets, because that's what that costs, right? That's the name of the game, right? This is a great little, again, service botnets. I'm going to show you a variation of this in a second. But these guys have this nice 100% antivirus non-detection guarantee because they use the cloud to spin up all the antivirus. So they can guarantee you that the malware that you gave to them will go undetected, right? At least until you use it. And screw up because you let the other guys know that something was wrong, and then they figure it out, right? The thing about Ashley Madison, I'm not sure how much you guys saw about this. This is basically a website that says, let's have an affair, right? Blah, blah, blah. They got all the data dumped. In a way, the tragedy is they didn't realize that the credit cards were not the value bid. So, of course, the joke is how great customer service of Ashley Madison, so the day after your husband or wife divorces you and kicks you out of the house, your card still works, right? Isn't that great? You still can go to a hotel, your card has not been compromised, right? Of course, but you see, in fact, last week I was doing a training, exactly the same thing. They have this great architecture, they're PCI compliant, which means that, guess what? Their credit cards are really well protected. Meaning here you have data that can affect people's lives, right? Criminal data, HR data, and it was totally unprotected. This will destroy their company. This is a bit embarrassing. This is kind of a bit of a fines. Anyway, the cards get revoked. The credit card companies know what they're doing. Actually, not a big deal. This will bring the company down, right? And then you need to understand where your assets are, right? Some examples of attacks. There's a great database. If you guys want, again, build a business case, there's the OWASP web application kind of incidents. These guys actually don't keep up to date because there's so much stuff these days, but there's enough stuff in there, like, some SQL injection, the guy did extortion. There's this great little tool that you can actually use blind SQL injection to download all the data, right, from the database, which is pretty interesting, right? Some XSS. I actually try to find some real case. So this is Apache gone compromised by JIRA via an XSS. Some pretty cool description if you guys want to see what the real attackers really do, right? And then you have, the MySpace worm, which totally changed the thing, because this was the moment that we realized that an XSS worm can actually blow up a whole website because it grows exponential, right? Which will, because, he compromised him, he compromised him, he compromised him. After a while, you're 7 degrees of bacon away from everybody else, right? Which is why Twitter these days pays a hell of a money if you find a vulnerability on it, right? And there's a lot of money being paid because it matters, because these things are serious, right? Now, man in the middle, very interesting, TJ Maxx, 94 million customers. That is a hell of a fine. They kind of blame it 1 billion. To be honest, these days they throw everything in the kitchen sink, right? Oh yeah, we need to do a whole native data center, just throw it in there. But it's still a lot of money, right? And it still costs a lot to deal with this stuff, right? Now, do you guys know about this one? Who know about this? Yes. So this, right, is something you can buy, right, from the US, right? To be honest, where's the Intel guys? Who's from Intel here? Come on, one of you guys must be. There you go. They can build the same thing, right? This basically, in fact, that little thing you were showing me that had Linux inside, this is what it is, right? It's just, a bit with a better Wi-Fi gear and stuff like that. This is, a man-in-the-middle platform, right, to do security research, right? Again, this is, of course, the kind of stuff you buy for $100. If you want to spend more money, you can get really, really small little things. If you think that's too big, you can always use this one, right, which kind of fits in your pocket, right? So that can go there. And basically what it means is you're walking down, and what this is doing is this is taking down the Wi-Fi network. This is pretending to be the Wi-Fi network. This is doing man-in-the-middle. This is basically compromising your own browsing environments or your customers. And if you think that's, again, too big, you can get this kit here, which actually, I got it here. And this is the only thing that's funny, right? You go, bloody hell, how many people are buying this stuff, right? So this has a whole bunch of stuff. He has another one of those, which is a bit smaller. You can see that's kind of the same thing as this one, just a little bit less powerful, right? There's a couple of stuff for Bluetooth hacking, some kind of keyloggers. And there's a really funny one, which is this dude here, right? Which is basically, again, you can see there's a sold-out dude. And then there's basically, again, by the way, you also have to be careful with your keyboards, right? And there's this guy here, which is basically the rubber ducky, right? Which is basically means that if he quacks like a keyboard and types like a keyboard, it must be a keyboard, right? So when you put this thing on your laptop, this thing has an Arduino, which I could have pre-programmed to run commands as you. Right? Again, if your security model depends on nobody to buy one of these, put a nice little logo, right, of your company to say, hey, here it is, right? If that's it, if this is your security posture, you have bigger problems, right? Again, this is not the problem. The fact that this is possible, it's not the problem. This is just a symptom of the thing, right? And by the way, this is kind of what man-in-the-middle looks like, which is crazy that we still have educated every single one of you guys to go where? You can even do this with your eyes closed, I guarantee you. You know how to go there, click on the link there's going to be about 100 pixels below, and then go OK, right? And this is all DevOps. You do this, you have a failure of DevOps, because it means you haven't figured out how to even freaking manage an SSL cert inside your network, which is not that hard, right? Now, again, we can start to attack cars. Finally, the FBI realized that it was a problem, right? This is ridiculous. If you read this, it starts to read the thing was, hey, it's almost to say, careful where you drive. Be careful with the Wi-Fi networks that you connect to. Be careful with the devices that the people that are going to your car have it. It's like, welcome to the world of cars, to the world of security that we've been having. But this is now starts to be real, right? So it's quite interesting, right? And if you want to read this report, this is one of the guys that managed to hack a car remotely, right? Again, denial of service, this is quite interesting. I don't know if you guys play with SynFloods. I worked for the company that actually got the whole brought down because of this, right? Again, still very sophisticated. That's why Akamai is making a shitload of money these days, because they're the guys who can handle this kind of stuff, right? Again, brute force attacks is some interesting logs that I actually got from one of our things. At least, would you even detect them? Right? At least we start to pay attention. Would you even know that they're happening? Right? Attacking the clouds. Most of you guys are moving to AWS and Azure and all that stuff, and Google Cloud. There's some really great exploits going on. Again, you guys should pay attention. That's a great presentation, right? That you want to do that. And of course, these days, you put your AWS key on GitHub, and it's guaranteed that within half an hour, there's people mining Bitcoins, right, with that thing. Right? And that's because there's a business model, right? And in fact, I've seen cases of attacks where they actually went after the keys. When the guys were inside poking around, they go, hey, cool. Well, we just found a key left on a source control system or it's hanging around the network. Guess what? Mining Bitcoin straight away, right? Because you can make money with it, right? Again, Google Darts, I don't know if you guys seen this stuff, but it's pretty cool. You go to this website, gets a database, then you can find all sorts of stuff from passwords. You can also get exploits, find the latest version, find people using that, then have a nice little exploit, right? And this, again, these are kids. You have to remember that this is not the criminals. The criminals do this at a completely different level, right? Again, this is pretty cool. It's Punk Spider. There's some website that decides to hack the world and find XSS and cross-site scriptings and a bunch of other stuff, and then give you a nice search engine, right, to search it. So you can go in there, you can find something like UK, there you go, and then you find a nice SQL Server injection service, right? So again, you don't even need a botnet because that will give you remote code execution on that box, right? So again, attacking the Internet of Stuff. There's this thing called Shodan, where basically you can find all sorts of Internet of Things that happen to be plugged to the Internet, right? Again, this thing scans and finds them and catalogs them and gives you kind of a nice thing. Again, this is not the problem. This is just telling you the stuff. And then we are really going to cyber war. If you guys, there's a great book, actually, I forgot to put the screenshot here, called Countdown to Zero Day, and it's absolutely interesting, right? If you read how Stuxnet's work, it is freaking impressive, right? 5 0 days, multi-stage payloads, right? Really professional, dynamic hooking, the actual, what's it called, control sensor in the language, all sorts of stuff. Fascinating, right? Again, this is what the governments are doing, right? And the real criminals, right? Because they're doing. Okay, and then there's the real criminals, right? Which do this kind of stuff, right? They basically hack into a company, figure out all their web servers are nicely vulnerable, and they're able to control the market, right? Which is what happened here. Or guys like Spread using ransomware from via poisoned ads, or guys like rogue payday brokers hacking websites to include website traffic, right? Kind of stuff. And this is actually a very nice video you guys should see. It's basically this dude that went to DEF CON and say, hey, can you hack me, right? And it's freaking crazy, right? The guy literally, you could see he starts really relaxed. By the end of it, he's like totally stressed about to throw his computer to the river and says, I'm going to change my profession. So it's really interesting. And half of it is actually social engineering. Half of it is, the fact that, again, we are very thin defenses. So some quick stuff might happen: mass supermarket failure, banks, fabricated news, mass identity theft, medical systems breaking out, blah, 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 crashes, the whole thing goes down, right? Because it's the whole freaking society, it's in technology, right? If you want to read more stuff, read this book, and it'll freak you out, right? Because you realize that in fact, if you're malicious, you realize that you need to change your business because these guys are making a shitload of money. But if you're a good guy, you realize that we really need to start taking this seriously. Now, TalkTalk was a big thing in the UK, right? They got compromised, massive lies, super sophisticated, yada, 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 with some freaking kids, right? Who are doing this stuff. But what's interesting is there's some interesting questions being asked. What's interesting about TalkTalk is they didn't get away with it, right? So she actually is testifying in Parliament, right? She actually has to go there, and it's very funny because we look at the annual report, some dude and says, hey, where's AppSec? And then, interesting enough, their stock price went down, which sometimes doesn't always happen, right? And that kind of was just some good sales, but you could see definitely the price is going down for quite substantially, right? And they actually had at least something like 15 million. So again, if you think about the investment you should do, right, now they're really paying. Of course, now they make it 60 million because they're throwing a whole bunch of other stuff in there, but it's still a lot of money, right? What's interesting about this, and I put the evidence here if you guys want to read, it's kind of interesting, the evolution, right? So you could skip this, blah, 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 right? There's some good stuff in here, right? Ultimately, it's still about the damage, which is annoying, right? But what's nice about this is there's a new report that came out, and she's taking ownership. And she actually saying something which I think is very interesting. She's saying they've been acting like a startup, which is a kind of great cop-out, right? But actually, it makes sense. They're basically saying that they were not taking it seriously. They were trying to innovate fast, yada, yada, yada. Sorry, we didn't really check about security, which is interesting, right? Because not every company has admitted that, right? So, all right, moving on to system identities. You guys can probably check this website. If you haven't, this is a secure researcher that has been cataloging all the latest dumps, which are these ones, and these ones, and these ones, and this one. There's a whole pile of stuff being out there, right? And he also did a great thing where he's mapping the pastes. So he looks at pastebin, captures it, monitors the pastebin, and then when people put stuff like this on pastebin, he actually adds an alert, right? Pretty cool service. This is actually quite funny, right? So these guys post this pastebin. I Googled the MD5. I found this website which is like on a queue to be cracked. It's almost like this nice little funny ecosystem, right? That's going on, right? And again, there's like the Facebook password, right? All right, cool. And then you can see 95 websites, 307 million, 34 pages, blah, 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 right? They're starting to be real numbers these days, right? Again, this is what the criminals are doing, right? The criminals do this, but they don't tell you anybody because they harvest it, and then they use it for login stuff and all kinds of things. Right? All right, bug bounties. This is very interesting, right? Bug bounties when people pay you to find stuff. These days, they're a sign of application security maturity. It means if you don't have one, you say, hey, hack me, right? Because I'm not comfortable enough to say to the world, please hack me. And it means they don't have a security team, right? Or at least you don't have one on the way to become very mature, right? So there you go. If you guys want to hack, these days, you can just go out there, pick one of these companies, and you'll be paid, which is pretty cool, right? So these guys, have pretty well mature stuff, right? And then, GitHub has this nice little thingy, stuff like that. Again, these jobs, these guys all get great jobs because when they go to job interview, they go, there's my CV, right? So again, it works pretty well. This is the kind of rules of engagement. You can see there's a bit of money for remote injection, yada, 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 right? And even the freaking US government is saying, please hackers, right? Which makes you say, where's the rest of the European governments? Where's the Italian government, the Portuguese government, the UK government? They finally realize that they need to play this game, that the guys that tell them they have a problem, they're not the problem, they are your friends, right? Okay, I want to guys do a quick demo. Hopefully this will work, and I am going to see if this works quickly. So one of the things, the key things I want to say to you guys is that I can look at a website and I can tell a lot about the website's security posture, right? Just by looking at it. So for example, if I look at this website, and this is kind of a cheap shot, but I presented these guys and they're software craftsmen, so they kind of should care about quality, right? Is first of all, no SSL, right? Which basically teams they don't have, most likely don't have deployment. I look at the page source, and the JavaScripts are not minimized, which basically means they most likely don't have a continuous deployment because that is really cheap to do when you have continuous deployment. I look at here, and they have a templating language, which is good, but it means that templating language is, in this case, is not escaping by default, which basically means if you get a payload from the server side, that thing will actually now pop into JavaScript, right? Which is what I got here for you guys to see. So for example, here you could see that I kind of modified to saying, hey, it's also well-crafted secure software, stealth adding value, AppSec professionals, and I also put an image in there with some JavaScript, which I popped, right? Now, what I'm doing here is I'm basically simulating what you do with this stuff, right? So what you see here is what you can do if you have one of these guys in the middle. So what I'm going to do, hopefully, I'm online. I'm going to go to Google, right? Where are we? Google.com, right? And come on, Wi-Fi network. Okay, Google for IT. All right, now I don't want that. Right? Okay, doesn't like that. Can I go to the BBC? All right, and all right, that's annoying. All right, so what I was going to show you, I was going to show that I can modify the content of BBC by just manipulating the thing going through. And what I was also going to do is I was going to actually fire Docker. If you guys haven't seen Docker, this is what Docker looks like. You go Docker, you attach the thing, right? And then basically you have a nice little Linux distribution, right? Just for you to play, right? And then you can go and you can run STUM. And then this basically has a nice little command and control website, which is called Beef, which I have here. And basically I would run it from here, and I was able to compromise that box from here. So this is not going to happen, so I'll just show you the control center, right? And this is basically what the criminals will do, is they will sell access to stuff like this, and then I was able to run commands, all sorts of stuff from manipulating data, get stuff, get their location, all that jazz, just from here. I can even put Clippy, which is also quite nice to annoy the users, right? But okay, so you can actually see this. So I manipulate the BBC IDs, right? Oh, actually, no, there's one more little thing. One more little thing is that these guys on the manifest, they do this. So if you go here, you could see that when I go into my search, I go into there, that Doug is going to send a request, which you can see here. That's just basically JavaScript being fetched. Basically, this is kind of there's a race condition. And when I talk about tests, I mean that you should be able to create stuff like this. So what you have here are basically there are tests that now check. As I send more data to it, you can see 0, 1, 31. I'm sending wildcards. I check the length, I check the time, I check the contents, and eventually I send a wildcard. You can see I'm getting more and more data, 48, 700, 5,000. And if I send these free requests here, right, it means that the website, see the website's live, hopefully? Yeah, cool. See, website's live, a couple of seconds. I'm going to run that test, which basically sends that request 3 times. And once I send that request 3 times, okay, let me just exit this guy, exit presentation mode. Once I run these requests 3 times, which I do like this, you can see I basically send 3 requests and the website's down, right? And that's 3 requests to basically crash the whole website. If I send 20, the whole thing would be down, right? And again, this is not very hard to do because all you have to do is find the place on the application that take more than 1 or 2x the other thing. You hit them a little bit, right? And especially if you do Node is crazily simple to send 20,000 requests to your server, right? So could you handle that? All right, quickly. Basically, right, we really screwed up, right? That's kind of the point, right? Now, the good news, right, don't panic, that's fine, right? Because unless you directly target, it's very unlikely that you're going to be hit, right? So that's the good news, right? Because if you've been hit, you already have a company. So basically it's not because you're secure, right? But it's because there are not enough attackers, right? So that's most of you guys' security model is there's not enough attackers, and you want to make sure your boss understand that, right? So basically, the reality is that. So I just want to flick back to my presentation mode. Where's my? Oh, sorry. Built-in. Where's the thingy? Oh, got a Windows. What's going on here? No. Oh, cool. There you go. Cool. All right. So here you go. All right. So basically, the reality is the attackers have not figured out. So let's go back. Basically, the reason you have been attacked is not because you're secure, is because there are not enough attackers, and the business model of the current business model of the attackers has not evolved to the next level where they find a way to make money with you, right? So here's the thing. So the next generation of application security thinking, it's about tools and techniques that they're designed to improve code quality and make AppSec possible, right? That's the key, right? So you have things like TDD with code coverage, where every single change must have tests. And code coverage is key to understand the impact, and everybody should be communicating with tests, right? That is critical. Threat models, which in other words is get a freaking decent brief, right? Well, it's crazy. You go to a company and says, how does it work? They got a pen and paper and drawing, right? It's like, whoa, imagine going to a building and say, hey, how does the building work? And the guy starts to draw a building, right? And you go, I'm not sure I'm very comfortable with that, right? So threat models are great. They're technical briefs. They should be done for applications, component features, right? Docker is amazing, right? Docker allows you to provide repeatable and destroyable QA environments, enable DevOps. It's really the next paradigm, right? This is kind of static, dynamic, interactive, and application firewalls, all that kind of stuff you should be doing. Test automations, you should really run tests on every single commit with every single branch. If you use Travers, that's something that you do every day. If you don't, you really should be doing it, right? It makes a big difference, right? Clever fuzzing is when you use your unit test to fuzz the whole thing. I'll talk about this workflow in a second. Kanban is really powerful. Again, freaking Scrum these days tends to be more a religion, right? It's ironic, like you have these Scrum things supposed to be agile. They're the least agile things you can think of, right? So basically, you need to visualize your web services. These days, I realize, my view is you have more than 10 web services, and probably 20, 30, 50. The only question is, have you admitted or not that you don't control them? Right? And you don't understand the interaction between your web services. You need to visualize them, and this visualization has to be done programmatically from the code. Right? So again, ELK is amazing. You guys need to do this across the board because this really, when developers are using this every day, it makes a massive difference. Right? Now, again, to say, these tools are designed to improve code quality and to make it possible. Until you do that, you're not really playing the application security game. Right? And because the reality, and you will have a development problem, not an application security problem, right? So here's the thing, right, about quality. When we talk about quality, we have these great quotes, right? Like, it's elegant and efficient. It's simple and direct. Well-designed prose. It has to be read and cleansed by the guy, enhanced by somebody else. Clean code, and I got the book here, right? This thing here, right? It's basically, this is all great, but this is very fuzzy. Like, how the hell do we measure this thing? Right? What's interesting is when we do application security, we can actually measure, because the key concept here is how do you define quality? So basically, in a way, how do you measure it, right? Because you might know your quality. How do you actually measure that thing? So when you talk about application security, the reason we can measure it is because, in a way, not all software quality, right, are application security, but actually all software security issues are quality issues, right? Because it's basically what we're doing is we basically measuring the non-functional requirements of software. We're measuring how it works. We're trying to figure out really how it works under the hood. And that gives you basically in a way that you can measure it because you're measuring the unintended side effects of code. It's all those things that you guys call technical debt and things that are not wrong. That's what creates the vulnerabilities in a lot of cases, right? Pollution is a great analogy for software because these are rivers catching fire in the US 70 years ago. And people's response was to build a fireproof dock and get the boats out of the way, right? Instead of realize, why is our river so polluted, right? People will say that factories are great because they give you jobs. The reality is, if we talk about technical debt, that's a great bad analogy because you are the guys who pay the debt. Right? Pollution is a much better analogy, and I show you the trick to deal with that is you make your managers accept risk. Right? There's another very interesting myth on secure code, which is the fact that software developers, if they knew security, they could write secure code. Right? That is totally wrong. Right? Because a lot of times secure code has nothing to do with developer skills and craftsmanship. Yes, there's some cosmical sequence of events where that will make a difference, but in most times, what we have is you look at the software development environment and you see the quality of the code being created, right? That's the bottom line. And I realize, because I can't write secure code, and I think I'm a pretty decent programmer, I'm a pretty secure professional, and I realize I cannot write secure code out of the bat. I can review it later, but it doesn't come out secure straight away unless I have a lot of visibility, right? This is the key to make the whole thing work, right? If you guys use JIRA, you can use this. If you don't use JIRA, use a variation of it. There's a nice fixing flow where the whole thing goes and you have a nice test. The magic part is here, is when, if you're not going to fix it, you have to make your manager click that little button in JIRA to risk accept. Right? And the thing about this, and there's a nice flow here for you guys to read, is that then we can map INFOSEC stuff to JIRA. We can actually have tests that are mapped, that you run straight away, that you check the security properties of the risk that you have accepted, right? That makes a massive difference. You can create dashboards. You can create weekly emails reminding, hey, guess what? This is the stuff that you have accepted. And this goes all the way to the board, right? And basically, as long as all the tests pass, you're making sure that it's your boss who gets fired, right? And then he makes sure that his boss gets fired all the way to the CTO, right? Because this is about having responsibility. It's not about having those bugs that live forever in the kind of to-do pile or, we'll look at it later, right? It's about making accountability. If you're not going to spend the resources to clean up, then you have to accept the risk. That's the key, right? Testing is critical, right? It's like this, if you make a change, you don't test, you are making random changes to your application, right? That's the bottom line, right? Here's the thing. People ask me this or they blog about this. How do you convince your manager? You don't. You fire him. Right? Because if your manager, right, is not asking you to do solid, secure, testable, provable, readable, maintainable, and basically deliver quality code, you need to sack him, right? Because that's part of his job, right? And if your company doesn't reward that, that's the problem, not the developers. And if you have this great thing where basically people think that, 97% code coverage, blah, 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 that's not a destination, right? That's the beginning. You're here in your path when you have 99% code coverage. It's only then that you can play an very interesting game, because without that, there's a whole bunch of stuff that you haven't even figured out, right? I guarantee you have 100% code coverage, you're this close to having Docker on it, because you already solved a lot of problems, right? And the other thing, right, again, 90% is just management requirements being gamed by devs, and you have a lot of stupid tests, i.e. you probably have 99.1% or 999.0.1. Again, sack the manager for that, right? Because this is not a game, right? This is about proper engineering. So again, this is what your managers and your application should be asking for you guys to do. And to make it effective, you need to do with IDE real time. So I showed this before. You need an environment where when you run the code, when you lift your hands, the code runs. Right? This is critical. If you guys are not using tools like Wallaby or nCrunch or IntelliJ or other customizations where this is an environment where I lift my hand, the code runs, right? And I get code coverage. So the crazy thing of this is now you can figure out how to do the missing bits of the test. This is crazy. This is me figuring out that the HTML title actually is vulnerable to cross-site scripting. And I can prove it because I wrote a test for it. And then here's where I can check the other ones. This is other stuff that you guys can check. There's a very cool one here where you basically can see me debugging using this. So by the way, if you guys use your debugger, you're already failing because it means you don't understand your code enough. When you have environments like this, you don't need a debugger. Right? Because you get state. This gives me real-time code coverage. I change a line here, I see exactly where it's breaking. This is crazy, this one here, right? I'm doing a UI in AngularJS where I get a screenshot, right? I could actually draw it on browser automation, but in this case, I could even render it, right? This is another one where I was actually, nCrunch is so fast that I was writing a unit test to check for something, and I was writing a test which basically said search catch, and the next line was deleted, but it was actually creating a folder in between my keystrokes, right? That's what you want. That's a great problem to have, right? And this is great stuff. This guy mutates the code and runs the test. If your tests don't fail, it means you don't understand what's going on, right? Again, why you want to do application security? You guys care. I'll talk about this. This is basically the big thing: is security of your code versus motivation of your attackers, right? Most of you guys are creating a perfect storm because you're adding this stuff, right? If you guys don't have a lot of stuff, right? This is actually some good things to just take a look at. If you have this, you're telling the world I'm insecure, right? And basically, you need to create this. AppSec team, security champion. This is a great article about it. So if you're not doing all this stuff, you basically have a lot of security, right? That's kind of the bottom line, right? You need to invest in application security because, and this is the key, right? If you do invest in application security, and it's easy to ask for investment in application security, you will actually improve the quality of your code. That's the game. When you attack, it's easy to do this. The challenge is to do this without being attacked. I'm trying to hopefully give you a way to do this without being attacked because you care about this, right? And again, if you're managers, you need to be doing this kind of stuff. Here's a nice 600K investment if you really want to do it. If your manager says, I want to do it, well, give him this bill, right? And then if they actually do it, then they mean. If they don't mean, then that's it. You say, okay, I'll call you 6 months. So if you attack, it's your fault, right? All right, we have a bunch of solutions, right? There's a great presentation again, Etsy. It's a great company to model yourselves out of, right? There's a great OWASP summit. There's a great conference here, right? Happening in Rome in July, June? Last June, so you guys should go. It's OWASP conference, right? There's a whole bunch of interesting SDLs. There's the BSIMM, there's the Microsoft one. There's some cool articles out there, right? And there's some cool tools these days, like this for 2FA, right? Again, you should deploy like GitHub 170 times a day, right? Now we're talking, right? And there's some cool stuff on Spotify, right? And final 3 thoughts for you guys to live with, right? First of all is every API is destined to be connected to the internet, right? Even if it's internal today, one day it will be there. Most data will be exposed to a web page, which basically means you put HTML on it, you'll be weaponized. And would you guys fly, right, on a plane that has the quality of your code, right? Because that's what it really means, right? So the bottom line is we can actually use application security to define and measure software quality, and that's kind of my vision for you guys. Thank you. Look at that.